In today's lesson, 4.5, we're going to look at solving polynomial equations. Now we're going to split this up into 2 days. The first day is primarily about graphing and using the factoring tools that we learned in 4.4 to help us find the solutions in today's lesson. The first thing we'll take a look at in our first term is a repeated solution. Now this is important because when a solution repeats, there are two things that you need to pay attention to. First one, it says when f of x, which is the function, is raised to an even power, it's telling us that the function does not cross the x-axis at that solution. So for example, right there, I put if f of x equals to x minus 2 quantity squared, or you're going to have a repeated solution, because if you were to solve it out, you have x minus 2 times x minus 2. And if you set both of those binomials equal to 0, then you'll end up with positive 2. So what that tells me is that the function does not cross at positive 2 along the x-axis. It may touch it, but it's not going to actually intersect. So, in the next scenario right here is when f of x is raised to an odd power. That means that the function will actually cross the x-axis at that point. So in the example shown, if f of x is equal to x minus 2 to the third power, you're going to have 3 repeated solutions. And so what that means right here is that at positive 2, your function will actually cross and do something like this. With the first one, right here, with f of x is equal to negative 2x squared, or negative x minus 2 quantity squared, sorry, there's positive 2. What they're saying is that it's not going to cross, but it will touch it and then go back up. Like a parabola, right? That one's your basic parabola. And it's a horizontal shift 2 units. So, and hopefully it all comes together and makes sense to you. The part about rational root theorem, we will come back to that in 4.5b. So let's go ahead right here, take that concept and help us solve some of these equations. All right. Remember, what you're doing essentially is factoring and solving things out. Okay, so you should be able to solve your equations by being able to factor, at least so far today. You can't use the quadratic formula because the quadratic formula only works when you have x squared as the degree of the polynomial, and that's not the case right here. So remember, let's start off with number 1 and let's see what we could do first. All right, one of the first things you should always look out for is GCF. And I see right here, I could factor out an r. And so I'm left with 36 r squared minus 1 is equal to 0. What do you do next? Inside my binomial right here, it's one of my special ones. Which one is it? Difference of 2 squares. So remember, the reason why is because 1, there's a minus sign. 2, I know, hey, I could take the square root of 36 r squared. I could take the square root of 1. So let's go ahead and do that. Remember, the square root of 36 is 6, and the square root of r squared is r. So that's going to get me 6r. The square root of 1 is 1, so we have 6r plus 1. 6r minus 1 is my second binomial by using the difference of 2 squares. So let's go ahead and get our solutions, and it looks like we have 3 solutions right here. Don't forget, the first one is this r. Even though it's out there by itself, set it equals 0, and there's one solution. You take the 6r plus 1, set it equal to 0. 6r is equal to negative 1, r is equal to negative 1 over 6. And let's repeat. 6r minus 1 equals 0. We'll add 1 to both sides. Divide both sides by 6, and r is equal to 1/6. So we have three solutions right here, and we have now solved the equation. And when you look at everything, remember, it's all based off of factoring. You want to take the equations, set it equal to 0, and then factor it out. Sum of two cubes, difference of two squares, difference of two cubes. All those things that we learned. All right. Continuing on, we're going to practice more of this. Let's take a look at number 2. So right here, one of the things that I just mentioned is let's take our equations, and we should always set it equal to 0. So I want to go ahead and add 60x to both sides. And then there's my function. You guys might need more space, okay? Just so that you can neatly organize your work. Might not have enough right here. So what can I do now? Okay. Or always look for GCF first. Looks like I could factor out a 20x. Okay, so we're going to divide everything by 20x and see what we get. We come up with, first off, x squared. Then we have plus 4x plus 3. Nice. It's a simple trinomial right there. We could factor this. What are factors of 3 that add up to 4? It will be 3 and 1. So let's go ahead and rewrite our equation by factoring. We have x plus 3, and then x plus 1. Right, if you were to FOIL this, you would get x squared plus 4x plus 3. Looks like right here we have three answers, three solutions again. So 20x is equal to 0. Divide both sides by 20. X is equal to 0. X plus 3 equals 0. X is equal to negative 3. And then we have x plus 1 equal to 0. And x is equal to negative 1. Three solutions. And take a look right here. The degree of the polynomial is x to the third. So there is a possibility that you will have a maximum of 3 solutions based off of that as well. Just like when we have x squared, like our quadratic, there is a possibility of 2 solutions, right? Remember, when we talked about the discriminant, you can have 2 solutions or 2 real solutions. You could have 1 solution, or you could now have 2 imaginary solutions. In Algebra 1, we just said that it was no solution. But now, it's actually 2 imaginary, since we now know about imaginary numbers. All right, next problem. Let's go ahead and set this equal 0. So let's see. I like having the degree of the polynomial to be positive. So let me go ahead right here. I want to subtract 3m squared to both sides. The reason why I did that, I like having the degree of the polynomial, or the highest power, to be positive, if at all possible, right? Sometimes it can't be, and it's a reflection, right? But right here we can, so let's do that. So let's see what I can do now. GCF. Looks like I could factor out a 3m squared. And by doing that, 75 divided by 3 is 25. M to the 4th divided by m squared is m squared. And then right here we got minus 1. Now what? We keep talking about this. Look at the binomial right here. Difference of 2 squares. This can factor out. Why? The square root of 25m squared is 25m. The square root of 1 is 1. We have a minus sign in between, so we can go ahead and write our binomial as 25m plus 1 and 25m minus 1. And that's why we stress so much difference of 2 squares in Algebra 1. And then I also mentioned it quite a bit in the last lesson in 4.4. If you're still having a hard time with it, make sure you can come by during tutorial, or I'm sure there are a lot of videos that talk about difference of two squares that you could check out. Okay, so we're going to go ahead and find our solutions here. You got 3m squared is equal to 0, and m squared is equal to, divide both sides by 3, is 0, and m is equal to 0. Okay, so there's one solution, m is equal to 0. We got 25m plus 1 is equal to 0. We got 25m is equal to negative 1. Divide both sides by 25m, and negative 1 over 25 is another solution. And you know what? I don't know what I'm tripping right here. Let's go back. Remember, the square root of 25 is 5, so maybe you noticed that. And I got to go back and fix this right here. So we got 5m plus 1 times 5m minus 1. All right, so let's go ahead. We'll do this again. 5m plus 1 equals 0. 5m is equal to negative 1. Divide both sides by 5, and m is equal to negative 1/5. If we repeat this over here, 5m minus 1 equals 0. 5m is equal to positive 1 by adding 1 to both sides, and m is equal to positive 1/5. So once again, we've got 3 solutions. All right. Let's take a look next. Let's look at number 5. All right. Another problem similar to something you saw in 4.4. I've got 4 different terms right here. And remember, we should take this and set it equal to 0. So let's go ahead. 2x to the third minus x squared minus 2x. And let me add a 1 right there. Now we have it set equal to 0. So from here, I've got 4 terms. And one of the things that we talked about in 4.4 when we have 4 terms is grouping. So I will take the first 2 terms and I will take the second 2 and put parentheses around it. Don't forget, in that second term, take the sign with it. It is absolutely important. So remember, one of the main things right here is let's factor things out, and we have to make sure that the binomials inside are the same. Looks like right here, the first binomial, let me factor out an x squared. And so now I'm left with 2x minus 1. Now, you see right here, I got negative 2x plus 1, but I need it to be the same thing as 2x minus 1. If I can't do that, then I can't factor by grouping. So now in order for that to happen, because it is possible right here, I'm going to have to factor out a negative 1. And that leaves me with 2x minus 1 is equal to 0. Okay. So how do I put my binomials together? Don't forget, what I have factored out is one binomial. Okay. What's common right here, that's your second binomial. So let me go ahead. I've got 2x minus 1 as one of my binomials. The second one is what I've factored out of each as x squared minus 1, and I want to combine that together. So now we can go ahead and solve things out. Oh, guess what? Look what I have right here. X squared minus 1. That's a difference of 2 squares. X plus 1, x minus 1. We'll set that equals 0, and we got the 2x minus 1 as our binomial. So we have 3 solutions here once again. You take the 2x minus 1 equals 0, you got 2x is equal to 1 when we add it to both sides, and x is equal to 1/2. There's one solution. X plus 1 equals 0, x is equal to negative 1. X minus 1 equals 0, x is equal to positive 1. We got 3 solutions right here, and now you know how to solve these equations. pretty much is what you did before, factoring in 4.4, except this time we're setting it equal to 0 and solving things out. All right, let's get down to number 7. We've got to find the zeros of the function and then sketch the graph. Now, it's not going to be perfect, okay? Things that we're going to use to help us graph things out is knowing the n values. Remember, we should know the n behaviors. And then what we're going to do first is make sure we find what the zeros are. Okay, so those are the two main things that we're going to be looking out for right here. All right, so let's see. Let's take our equation, x to the 4th minus x to the 3rd minus 12x squared. Set it equal to 0. Can we factor anything out? You bet. Hopefully you realize I can factor out x squared. And so I now have x squared minus x minus 12. Okay? So now, we could factor this some more, and we're left with factors of negative 12 that add up to negative 1, x minus 4, or 4, and x plus 3. So we've got right here several solutions. Let's take the x squared is equal to 0. Now remember, if I want to get x by itself, you have to technically, or you do have to square root both sides, and x is equal to plus or minus 0. Even though that's 0, it's important to us. Why? Because right here, this ends up being a repeated solution. Because x squared. Okay, so you do have to keep that in mind in this problem and to help us graph things out. We take x minus 4 equals 0, so x is equal to 4 is another solution. X minus 3 equals 0, and x is equal to negative, x plus 3 equals 0, and x equals negative 3. So we have right here a total of 4 solutions. One of them is repeated. Okay, so let's go ahead. I want to go ahead and place points right here on our graph. So we have at 0, we have one at 4, and then one at negative 3. Okay, so let's go ahead. I'll plot my points. And so remember, the first thing we talked about was that if the function or if the solution is even, it will not intersect. If the solution is odd, it will intersect the x-axis. Now, where should this start? Remember, the degree of the polynomial is x to the 4th, and it's positive, which means my n behavior should be upwards. So if I start right here, it should be up on the left-hand side, and what we could say is that it's going down. And it's going to go down through negative 3. Now, here's the thing. Without a graphing calculator, I don't know where exactly and how far down it goes and exactly where it's turning. I don't really mind too much, but what I do know is that it's going to go down and then it'll eventually go back up. And at 0, remember, if it's a repeated solution, it's not going to intersect. So it's going to touch 0 and then it's going to go back down and then it's going to intersect at positive 4. And then remember, from here it goes up. And there you have it. The n values, n behaviors, they're both going upwards, just like it should. It intersects where we only had one solution. It touched at 0 because it was a repeated solution. All right. And there you go. We are now able to graph. Let's take a look next at number 8. So let's repeat the steps here. Let's figure out what we can do. We have right here, looks like I could factor out an x. So let me go ahead and put 0 is equal to x times negative 4x squared plus 12x minus 9. Alright, so once again, things get a little more challenging right here because my a term is greater than 1. So we have to do a little bit of work, figure out what are factors of negative 4 and factors of negative 9, and do the little test right here to see what we can get. And let me try 2 and negative 2. All right, those are different factors that give me negative 4. And it looks like, let's see what happens if I try 3 and 3. Now one of these needs to be negative. It looks like it's going to have to be this one. Okay, so let's check this out. Let's see if it works. That right there, remember that's the outer terms in our FOIL. That gets me 6. This right here gets me 6 as well. Negative 2 times negative 3. And this adds up to 12. And guess what? My middle term is 12. I just figured it out. So let's go ahead now. We'll put all our binomials together. One of them is x, or find our solutions. Remember, one of the binomials is going to be 2x minus 3, because we go straight across when we write our binomials. And then the second one will be negative 2x plus 3. And we set these equal to 0 and we solve them out. Okay, x is equal to 0. That's one of our solutions. We take this right here, set it equal to 0. I got 2x is equal to 3. Divide both sides by 2. And x is equal to 3 halves. And then let's repeat it right here again. We got negative 2x is equal to negative 3. Divide both sides by negative 2. And x is equal to 3 halves. Oh, we got a repeated solution. Okay, so let's go ahead. We'll plot our points right here. We have x is equal to 0. We have 3 halves as another one. So 3 over 2 is 1.5, so I'll go ahead and place another point there. Let's take a look at our function. We have an odd power, and we have the coefficient being negative. So we got to figure, all right, if it's an odd exponent, it's going to go in opposite directions, right? One or the other. Which way does it go? Well, if it's negative, then it's going to reflect, right? Typically, it starts down at the bottom left and moves its way on up. But if it's going to reflect, it's going to start from the top left and go its way down. So let's go ahead. We'll start up here at the top left somewhere, and it's going to go down to 0. Remember, what does it do at 0? Does it just touch, or does it intersect? Remember, it's only one solution, so it should intersect. It goes through it. Eventually, it's going to have to go back up so that it could go to 3 halves. And because the solution is repeated, it will only touch it and then go back down. And this is the basic design of our function. Okay, it's an odd function. So therefore, I know, once again, I'm thinking about the end behaviors. Is it going opposite ways? And it is. And it's going to go down from left to right because of the negative in front. All right. I'll go over more of these just to help you guys out. Some of you guys need more practice with the factoring. So that'll be good practice for you guys. Okay. Taking a look at number 9, I'll try to go through this a little bit faster now. We'll start off. We have 4 terms, so that tells me that we should be doing some grouping right here. All right, so let's take the x to the third plus 4x squared. I could factor out an x squared. So I'll put this over here on the left, and we are now left with x plus 4. All right, so let's see right here. With this negative 6x minus 24, somehow I got to end up with x plus 4. It's possible if I have x, if I factor out a 6 or a negative 6. And that'll leave me with x plus 4 right here. All right. So now we have that. We got x plus 4 as one of our binomials. I have x squared minus 6 as another. All right. So let's take all of this. We'll set it equal to 0. And so one of our solutions is x is equal to negative 4. Now this one right here, it's x squared minus 6 equals 0. Don't think that just because there's an x squared in it that it's going to be a repeated solution. If we solve this out right here, x squared is, we'll add 6 to both sides, and then we square root, x is equal to plus or minus the square root of 6. So there's actually two separate solutions. All right, so we've got that right there. Let me go ahead and let's see. Put some lines down. So let me put a point right here at negative 4. 1, 2, 3, 4. Negative 4 is right there. Square root of 6. Let's see, I think that is approximately, you get about, what, 2.45? Right, let's see here. Now let's say it's about 2.45. So we have one at positive 2.45 and negative 2.45. We'll say it's like right around there. I look at the degree of the polynomial. It is odd. And behaviors. It starts down on the left side, it goes up on the right side. Now, there is also one other thing that I could determine based on the equation, and to help us out right here. It's this negative 24. You guys remember, what does that negative 24 represent? It's like your C term in a quadratic. That's your y-intercept. If you looked on numbers 7 and 8, they actually didn't have y-intercepts, right? It actually crossed at 0 at the origin, or touched the origin. But this one right here, we actually have the y-intercept. So if I were to say negative 24, we can't fit that in right here, unless we do like intervals of 6. So let's go ahead. If I were to do intervals of 6, we have 1, 2, 3, 4. This right here would be negative 24. And there's our y-intercept. So this is, once again, we know that it is even, or sorry, it's an odd power, odd degree. So but it's going to start down here, and it is going to go up to negative 4. Or since there's only one solution at negative 4, it's going to go through. And it's going to go ahead and come back down right here at square root of negative 6. Remember, I don't know how high this actually goes right here unless I start plugging in numbers or use a graphing calculator. So this part won't be accurate, but what I do know is that it's going to go through negative square root of 6, and then it's going to go all the way down this time to negative 24 because that's my y-intercept. And then from there, it could go further down. It could turn back up. Once again, we won't know that unless we actually use a calculator and find other terms. But I do know it's going to eventually go back up right here to positive 2.45. And then it's going to go all the way up right here past this. And that's the basic design of our function. All right. So hopefully we're continuing to practice factoring here. And if you're still having a hard time, once again, tutorial is where you got to come. All right. So make sure you're here at tutorial. Ask questions in class. Or you could always look online for other resources as well. All right. So good luck on this section right here.